Hi everyone, this is for the July 2, 2022, Saturday, session 2. First of all, I would like to thank all the IEEE TUAC committee members, attendees and the participants and our guest speakers. Now we will continue with the student presentations. Please try your best to complete the presentation in 15 minutes. Then we will have question and answer session for each paper presentation. First presentation is Optimal Tariff Recommendation Module by Mixed Integer Linear Programming by Furkan Koçak from Uludağ University and Derin Karadal from Eraslan High School. You can start the presentation. Can you share your screen? I cannot understand. Do you have the same problem?
21 years old. I live in Warsaw. I want to talk about our projects. Our project is our recommendation model by Mixed Integer Linear Programming.
We have a problem with your microphone.
This is the first presentation, program presentation, territory configuration, program interface, and test method.
Hi Furkan, we have a background noise problem. We cannot hear you.
Application which allows participants to access the current and optimal tire system. This program can facilitate people's daily lives by aiming for maximum efficiency and long-living field results such as increasing information pressure and change.
Furkan, can you hear us? We cannot hear you. There is a background noise. There is a background noise. We cannot hear you.
I have to hospital. Electricity the service burden on people also economy. Inspired by this event, we start to develop our project and other types of functions. Territory there article in America that it will make great contribution to monetary.
Furkan, we really cannot hear you anything. Derin, can you present?
Yes, I can continue.
Hi Furkan, we cannot hear you. We don't understand anything. So let's let Derin to present. Can you put your speaker to mute? Let's give Derin a chance to present. Thank you. Can you start, Derin?
Furkan, can you share the presentation? Or should I?
Better if you do it.
Yeah, Derin, if you can have the control, that's better.
Okay, I am ready. Sorry for this.
Furkan, we still have a background noise. So let's let Derin to present.
Okay, so I think you can view it.
Yes. Please go ahead and start.
Yes. Here is overview part. We're gonna talk about problem, presentation, literature view, contributions of it, program interface, tests and results. So the tariff suggestion program is a suggestion application which allows its participants to access to their current and optimal tariff systems. This program can facilitate people's daily lives by aiming for maximum efficiency and low billing fees due to reasons such as increasing pressure and climate change. Can you view all of the part? Because I can't see. Okay, I think this is better. Electricity will impose a serious burden on people's household economy. Inspired by this event, we started to develop our projects with other types. Literature view part. There are articles in America that it will make a great contribution to monetary savings when applied correctly. In Malaysia, a flat tariff is applied on residential customer disregard the time of use. Here is interface part. There is a video of it.
Can you give brief description while the video?
Yes, this is our basic application. It's Turkish, but here days of the bill and total energy. The consumer gives information about his bill and the program gives the best, the optimal tariff for the consumer. So this is interface of it and contributions part. So the application is able to serve all types of consumers defined by EPDK. This is Turkish, but it means energy market regularity. It has some consumers. You can see it's such as residential, commercial, industry, lighting, agriculture, irrigation, business. So let's start with residential. It is the home where people live and which belongs to them. Consumption here falls under the residential type tariffs. Commercial consumer. In developed or developing countries, the service sector is very common and accordingly ready consumption is high. People do activities such as eating and drinking coffee after work. So shopping malls are the reason that this has consumption very high. In Turkey, the coincidence with the peak time and increases the amount of the bill. Lightning, the sector with the highest electricity consumption is the empty lamp posts on the streets. So you can see there is always lamps on the street. So that's why this is the highest electricity, this has the highest consumption. Contrary to our program, object-sensitive lamps with photoelectricity should be developed. This is the test and results part. So to talk in general, if you spend more electricity in nighttime, according to peak and daytime, because of the nighttime fees are cheaper than the peak and daytime, so you have to choose 3-time tariff because like it's cheaper, you know. And if you spend more electricity in daytime and peak time than nighttime, you should choose 1-time tariff because it will be the same fee for all of the times. The invoice samples that we could reach showed us that the application made significant gains in the invoice amount of the consumers at right tariffs time. So future plans. When we start this project, our professor in Özyeğin University, he said that we should do this with QR codes. Like you show your bill to camera and program gives the best tariff for you. That can be used in future. In the future, mobile applications can be developed to reach more people. People will sign up and enter their consumption month by month, and at the end of the year, they will be told whether there is a right or wrong tariff according to the average. So that's all I'm going to say. Any questions?
Thank you, Derin and Furkan. Is there any question? Let's wait a couple seconds because there is a delay on YouTube if someone has a question. If not, I have a question. If you had a chance to test your algorithm with real data, for instance, your own home consumption.
Yes, Furkan did it. I couldn't find any bills, but Furkan did. He asked to his friends, I think, and the test and results part, we have the real bills.
Okay. If everyone does this and if everyone uses the night time, would this be a problem later?
I don't think so, because nobody will use only nighttime, and there is so much consumption in day and peak time. Even shopping malls or streets have it in peak time, especially. So that won't be a problem, I think.
Okay, thank you. I have no further question. If you guys have any question.
I see no questions on YouTube, Professor Ekti. But meanwhile, I think the next presenter is going to be, has already been.
Okay.
Yeah, that inside. Yeah, it's there.
We will go with the second presentation. And thank you, Derin and Furkan, for your efforts and presentation. And the second presentation of today will be Sleep Apnea Monitoring System by Fatma Nur Aytekin, Uğurcan Yolcu, Alper Uysal from Yaşar University.
Hi, I will share my screen right now. Can you see my screen, right?
Yes.
Okay.
You can start. Thank you.
Okay. Hi all, my name is Fatma Nur Aytekin. I will be presenting today's presentation. Project name is Sleep Apnea Monitoring System. To start my presentation, I would like to give you a definition of the sleep apnea first. Sleep apnea is a disorder that causes interruptions in breathing during sleep. And sleep apnea detected by a cold test called polysomnography. About the diagnosis rates in sleep apnea is really low in world. 80 to 90 of sleep apnea patients in the world haven't been diagnosed yet, and this rate thought to be 95 to 98 in Turkey. I will mention the reasons of this later. So move on to polysomnography. So what is polysomnography? This is a test method that used to detect sleep apnea. With this test, we can obtain EEG, ECG, EMG, which is muscle movements, chest and abdominal movements, oxygen saturations, and body position. In figure 2, you can see the traditional polysomnography test. So let's take a look of disadvantages of traditional approach. I said in slide 2, I I will tell you the reasons of why the diagnosis rates are so low. And this is the reason. Disadvantages of traditional approach are the reasons of the why the diagnosis rates so low in general in the world. Traditional polysomnography tests are wired system, old and expensive applications, difficult to implement on the patient. It takes patient out of their comfort zone. I have experienced once, it's really hard to sleep in the hospital or sleep center, so this all can affect the result of this test. And expert observation is required during the test period, which increases the cost. You can see the implementation of the polysomnography test in figure 3. In this part, so this brings me to aim of the project. This project aims to develop an easy-to-use, portable, and wireless sleep apnea monitoring system. And this system mechanism is like the equipment will be given the patient who apply with the sleep apnea suspicion. And important data will be collected for patient sleep apnea follow-up. This is project output actually summarizes how the system works. For the first part, we can see the EEG data. Second part represents ECG data, accelerometer data, which is accelerometer data give us the body position of the patient and the chest movement, so we can know how deep breathe the patients. And the pulse oximeter sensors, which is measures the blood level in the oxygen. These data are collecting and transferring to computer environment, and then monitoring the desired systems and saved for the doctor's consultation. For further, let's look at the diagram of the project. This project consists of 3 main parts, actually. First part, let me show. This part represents EEG data. We will use NurseSky Mindway Mobile 2, which I will mention later. And the second part is this is a chest model. We put gravity ECG sensor and MPU 1615 on a ESP32. Gravity ECG sensor measures the ECG, and MPU 6050 measures the accelerometer. Like I told you, accelerometer gives us the body position and the chest movement. And the third model represents the finger model. Then we connect ESP32 and Max 13100 model to measure blood oxygen, blood level in the patient. In NurseSky Mindway Mobile saves the data into Excel by using Bluetooth, but 2 other models, chest models and finger models, saves the data into Excel by using Wi-Fi. We coded the sensors by using Arduino, and we create a Python server for the wireless transmission. After the Excel file, we created an interface by using Python, and then interface shows the data saved from the Excel files. These are the example of Excel files. First one represents gravity and MPU 6015, which is the chest model. You can see the first raw ECG, acceleration, gyro, XY. There is no Z value because this is a two-dimensional movement. And the second one is max 31,000. And the other one is NERSky brain signals. About NERSky, NERSky is a single channel device. It measures the brain signal by using electrical potential difference principle. Between forehead sensor and the ear clip, there is, of course, a potential difference voltage, and it embedded with the TGM chip, and this TGM chips extract that signals into delta, theta, alpha, and the other brain signals. And we use think-ear connector and the neural experiment to interface to connect this device to a computer and get data. These are the implementation of two modules. This one is chest module and this one is finger module. These are the circuit design. And we design boxes for the easy use, and we print them out by using a 3D printer. Also, two modules has been powered with 3.7 voltage battery. And this is the interface of the project. You can see the brain signals, ECG, SpO2, which is the pulse oximeter, blood level on the oxygen. This interface created with Python. It consists of 5 Python files. Also, we can provide with this interface live data. Also, we can save data for doctor consultation, so you can go back and observe the other data. This is the completed system. This is NERSky. This is chest module. This is finger module, and there is no line, no wire between them, or there is no wire wired to go to a computer. And this is the interface. To sum up, I would like to remind you the aim of the project again. The project aim of this design a wireless and easy to use portable sleep apnea monitoring system. The circuit design has been completed and wireless data transfer completed successfully. Also, this project is supported by TUAC 3209A program. These are the references, and thank you for your attention.
Thank you for your presentation.
You're welcome.
And let's check first the YouTube chat if there's any question. There are
two
two
questions, Professor Zer.
There are two questions. One is, can you please explain the breath monitoring, and can it detect hypopnea as well?
This systems detects nothing. This is just observing system. You can think this system as a heart halter system. So there is no warning system in this project. This detects nothing. For the first question, I think it was breathing.
Yes, breath monitoring.
Okay.
Can you please explain the breath monitoring?
Breath monitor. Okay, so I would like to show the completed system. This is the finger model. It has the pulse oximeter, so you can detect the blood oxygen in the level, which is related with the breathing. Also, in the chest model, there is the accelerometer. With one accelerometer sensor, we obtain two data actually. One, body position. Two is the chest movement. So chest movement is give us the breath level. How deep breathes that patient. So actually we get breathing data from two models. I hope I can explain.
Okay, thank you. And we have no more questions on YouTube. I have a question.
Yes.
So you said this is just a collection, right? So you don't do any detection or classification, like someone is in sleep, has a sleep apnea problem or not. This is just the data collection system.
This is just a data collection system, and with this interface, we can provide live data. Also, we can save data.
Okay.
Yes.
So based on that, did you check the results that you obtained from your current system and the already existing system? How close the results are?
We checked. We tried this system on many people. My teammates, me. We are getting results, but we only can compare them with the some articles, not real results, because the KVK, we can't show the real patients. We can see the real patient's results, so we can only compare them with the articles or any other research results.
Okay, thank you.
You're welcome.
Is there any other question? Okay, there is one more question. I think it is similar to what I just asked. Did you try it on a real patient, and how the results compare to a conventional device?
Like I said before, because of the pandemic and the other conditions, we couldn't try real hospital system, real polysomnography traditional system. But like I said, we tried, and we only compare results with the article results, and it's not 100% same, of course, but it can be yeah, close. The results was close.
Okay, there is one more question. What would be the next stage of this project?
Like I said, for this project supported by TUAC, so our new work is on. We will not use Excel. We will create a database, and of course we have other future works like Nurse Sky connects with the Bluetooth. We try to turn it to a Wi-Fi using other sensors, and we are searching any other more sensitive and sensors, and maybe for other future studies, it can be combined with machine learning, maybe.
Okay. Let me check. There is no question on YouTube. I have one last question. Did you have a cost comparison of what you are using right now and the conventional device? Like, how much does it cost for you to provide this system?
This system is much more cheaper than the traditional. We have done it, but I didn't put in the this presentation. These sensors and are cheap, but the expensive one is the Nurse Sky. This prototype can be expensive, but still cheaper than the traditional one.
Okay, thank you. Maybe we can put this as a next stage to comparison and the data comparison and the cost comparison. Thank you for the presentation.
You're welcome.
So we are done with the session 2. Thank you for all the presenters and all the attendees and the participants. And all the IEEE TUAC committee for giving this opportunity. Thank you.
Thank you, Ali Rıza Hocam. So now we are closing this session and hope to see you tomorrow in the morning session.